on with content. I'm going to make sure that we're all on the same page. If you are having, I put out a survey today that I put out multiple times. If you're having an issue with technology, see me during my available times. They're posted in 5 different places. I'm not going to go over it again. That I asked you to write down in your notes. Is that clear? Okay. So you're going to see me for tech issues. You do have a quiz. Unfortunately, all this other stuff took up too much time. You'll have your quiz on Monday. You do have a practice quiz. You should go over it. And I'd like to try to do a practice quiz with you here together. Yeah. Read the practice quiz. Actually, read what I sent you a week ago. Did that sound sarcastic? Oh, good, because I was going for sarcasm. Great. Yeah.
Okay. So, does the quiz that we took yesterday count because
Oh, you guys took the quiz. Oh, no other class took it. I was thinking you guys didn't take it. So you guys took it. How'd you feel about the quiz? First I'd like to apologize for my sarcasm because you were right. What was the quiz on was a good question because you already took the quiz. You can use sarcasm me later. And I can't think of what else to say. So let's go. I'll ask the question again. I wasn't listening to all of you because I was feeling bad about being sarcastic to her when she was right. All right. So how do you feel you did on the quiz? No, I'll grade it and put it in. You want me to do that? No. Oh, okay. I mean, it's going to get graded. It's not a problem. The question, I'm asking you a question. How did you feel about the quiz? Yeah. All right, okay. Because of what? You had 15 minutes. It shouldn't take you more than 15 minutes to do this quiz. It's a bunch of fill-ins. And you'll see. We'll do it together. We'll do it together right now. We'll see. And maybe it's too long. Maybe you're right. I don't know. I was wrong already 3 times this morning, so I'm wrong all the time. Where is the quiz? You can't, if you're trusting a human being to be right 100% of the time, you're going to be disappointed a lot. Say what now? I can't hear you. Here, Pat, somebody I'll tell you what, I'll give you a minute. Come up and get these. Get your test. Hurry up. All right, I just want to verify. This is everyone in the room. Not any kind of some people. Everyone in the room has a quiz in front of them. I hear no no's. Okay, very good. So everyone should put your name on it. Consider this another practice quiz. I'll have to come up with a 3rd exam. You think you're going to get another? You think it's going to be the same quiz? You're going to go over? I'm going to give you the same quiz. All right, I'm moving on. So you put your name in here. Make sure you fill it in. It's a quiz. You have to know the content. How do you know what the state of Ohio or SAT or ACT are going to put on a test? You don't. It could come in many different forms. That's the nature of exams. This is not a test. This is a quiz. It's short. It's meant to be 15 minutes long. Maybe you're right. Maybe this takes too long. Let's see. Let's do it together. So lemon trees receiving the most water produce the most lemons. We have to identify the independent, dependent, as well as constants, right? where I obviously is independent, D is dependent, and C is constants. So if you're looking at an experiment that looks at trees, lemon trees, and producing the most water, gee, where have we worked at this? Where have we seen this kind of experiment before? Oh, we're doing one. Sarcasm again? Okay. All right. Hey, I gotta have fun too. All right, so lemon trees receiving the most water produce the most lemons. So what would be the independent variable? Yeah. Yeah.
The amount of water.
Water. And what would be the dependent variable? Yeah.
The lemons produced.
Lemons. Number of lemons. And what constants would you keep constant? Just one. You don't have to list all of them. Yeah. Sunlight. Done. Literally what we've been doing for 2 weeks. All right.
You said lemon tree was constant. Like it's a lemon tree, so it's always constant.
There's more than one answer to that, right?
There's a multiple. I'm not going to go through all the multiple answers of what's acceptable isn't. If you have a specific question, see me during my available times. I will answer those specific questions. Otherwise, we'll sit here for an hour going through all the different options. Because all right. The investigation found that more bushels of potatoes. You may not know what a bushel is. It's a measurement of. It's literally think of it as a bunch, a specific number for a bunch of potatoes were produced when the soil was fertilized more. What would be the independent variable? Yeah.
The amount of fertilizer.
Fertilizer. And the dependent variable? Yeah. Potatoes, number of potatoes. You can say number of bushels or whatever. Those two are not negotiable. They have to. That is the independent dependent variable. Period. Then it's something you kept constant.
Type of soil.
Soil type, water, light, all that, right? Okay. Why do you keep saying the? It can't be the same potato. Maybe the same potato plant, the same species. Yeah, it's the same species of lemon. That's true. And you could even say clones, the same clones of lemon trees or clones of potato plants. We can do that as well. Yes, you can keep that constant. Someone close the door, please. The students measured the temperature of water at different depths, Lake Skywalker, and found that the temperatures varied. Yeah.
Oh, maybe.
Yeah.
The depths in which they tested, like the depths of water.
The depths of water would be independent. And dependent? Temperature. Yeah, that's what I was thinking. The students measured the temperature at the different lengths and found that the temperature varied. No, that's correct. The depth was independent and the temperature was dependent on how deep you went. I'm sorry, I was distracted. So what would you keep constant? The lake. You could also keep constant the time of day you measured it. Because if you measured one at noon and one at night, what's going to happen? You're going to mess up your data. So the time of day, that kind of thing. Because obviously the sun heats up the water. At least I hope that's obvious. The amount of pollution produced by cars when was measured for cars using gasoline containing different amounts of lead. Okay, so what's the deep independent? Lead. Lead concentration. I'm going to use the square brackets again. So lead concentration. And then what's the dependent variable? Amount of pollution, exactly. All right. And what constant? Yeah. Ivy? The car, yeah. Type of car. That makes sense, right? If you use a truck versus a minivan, you're going to get a bigger amount of pollution from the truck because it's a bigger engine. All right. 4 groups of rats are first measured and fed identical diets except for the amount of vitamin A they receive. Okay. For each, now they already told you what did they tell you already? They told you already you know. Can I highlight some stuff for you? This is taking longer, so don't count this on my 15 minutes of my suggestion that this should take only 15 minutes. Four groups of rats. Four groups of rats are first massed, so it means they're measured. Their mass is measured, and fed identical diets. That's a constant. And then, except for the amount of vitamin A, independent variable. So right there, you got constant independent variable right away. For each of these different amounts, 3 weeks on the diet, the rats' masses are measured again to see if there was a decrease. And they already told you, therefore, that the mass, right, being measured is what? There you go. See, it's it's right. I mean, am I wrong when I say that this should have gone really quickly? Is this one of my mistakes? My examples of how many times I went wrong? But independent is the vitamin A. Do you agree? And dependent is the mass, and things controlled is the rest of diet. And yeah, you could have said the rats were the same species. You could have said that the rats were clones of one another, which we do that a lot in science. We use clones because you want to have a genetically identical. That's the best if you have comparison genetically identical beings to see the impact of one factor. So all right, so that's page 1 done. Let's look at the next. 2 groups of students were tested to compare speed of working math problems. Each group was given the same problem. Same problem is what? That's a constant. So there you go. And let me do this. Same problem. And what are you trying to 2 groups are tested to compare their speed of working math problems, which would be what? The dependent variable. One group used calculators and the other group used without calculators. So the independent variable is calc versus non-calc. All right, and then the dependent variable was speed, and the control was problem. The problem they said that they were given. You could have put the time of day. You could have put the amount of sunlight in the room. You could have put which room they tested in. All that could have been controls. Oh no, constants. I'm sorry, you're right. Not control. I could see question. That would be the control, the constant problem. So what? And there was a group of calculators and a group without calculators. So the group without calculators would be your control, right? All right, without the calculators, the control. Maybe go ahead and take non-calc out of here just to make sure that you're clear on what's going on. So the calculator, whether you have a calculator or not, is the independent variable. Your control group's going to be the one without calculators, and then you test the different groups and see what happens. All right, students. So you see that the control group is often one of the independents, right? It's one of the forms of the independent variable. So if you're looking, what can I use for a control? Look at the independent variable and choose a negative or positive control. In this case, it's a negative control without calculators. Students of different ages were given the same puzzle to assemble. The puzzle assembly time was measured. All right, so same puzzle, that means what? There's my constant. Oops. The puzzle assembly time was measured, so what's the independent variable? Time. Time.
Mr. Mendoza, I think it would be time for dependent variable.
Yes, you're absolutely right. My bad. Mistake number 1,359,000. All right, ages. And time is the dependent variable depending on ages. Every time I see time, I always want to put as independent. I don't know why. An experiment was performed to determine how the amount of coffee grounds could affect the taste of coffee. The same kind of coffee, the same percolator, the same. Oh, see, we got a lot of things that are same there, don't we? Same kind of coffee, same percolator, same amount and type of water. So those are constants. There's 3 constants. There they are. I'm not going to write it. 1, 2, and 3. All right. Oh, and the same percolating time. Oops. Didn't see that. Same percolating time. And same electrical sources. Wow, they only asked for 3, but they gave you 5. 4 and 5 were used. All right. Experiment 4 and determine how so what's the independent variable? Amount of grounds. Dependent variable? Taste. Right? And then 1, 2, 3, 4, and 5. I think it's pretty straightforward, right? I think the quiz was straightforward. It's okay that you didn't do well on the quiz, but well, let's go through the last one. It's okay, you didn't, and then you had, I think this is the last page, isn't it? Yeah. And I was going to give you 2 of these, but one didn't show up, so I let it go. SpongeBob notices that his pal Gary is suffering from slimatosis, which occurs when the shell develops a nasty slime and gives off a horrible odor. So slimatosis, they're describing what slimatosis is. His friend Patrick tells him that rubbing seaweed on the shell is a perfect cure, while Sandy says that drinking kelp, Dr. Kelp's will be a better cure. SpongeBob decides to test his cure on rubbing Gary with seaweed for a week and having him drink kelp. After a week of treatment, the slime is gone and Gary's shell smells better. What was the initial observation?
Gary suffering from symptoms.
Sickness. I'm just going to put sickness. You can put slimatosis. You can say bad odor. Any of those are fine. What is the independent variable?
The seaweed and Dr. Kelp's drink.
Right, seaweed. Why was this? Why did it ask you? Okay, yeah, seaweed and Dr. Kelp. Solution, all right? And that's I put that as solution, SOL solution, right? What is the dependent variable?
The slime that is there and the amount of smell there is.
Say that again.
The slime that's there.
And slime and smell, okay, slime and smell. Illness, get better. There's a lot of options you can phrase it, yeah?
Are you asking about the conclusion?
Oh, yeah, the conclusion, go ahead, yeah.
Well, okay, I'm just gonna read whatever. For an experiment to be useful, only one variable should be manipulated. Since SpongeBob used 2 independent variables, he cannot determine what variable worked / which one didn't. His experiment was inconclusive.
And that's the problem we ran into in our experiment, wasn't it? Too many variables changed, and we couldn't compare our data. So that is exactly right. It's inconclusive. You can't come up. It's something that's really common sense, if that's a real thing. Common sense would have a lot of people say, it works. Let's do it. But a scientist would ask, let's do what? Mr. Kelps or seaweed? By the way, did that take us 15 minutes? How long did it take us? Anybody time it? It did not take us an hour. Please stop. Yeah, it took about 20 minutes with 5 minutes worth of explanations and checking and verifying and having conversations. So 15 minutes was not an unreasonable time for this quiz. Do you all agree? All right. If you needed more time, that's always available to you. If there's an issue, we could talk about that. Again.